Hi everyone, and welcome back to our 7-part series of Generative Design for Solid Edge 2019. For those of you who have been following, welcome back, and for those of you who haven't, definitely check out our previous videos. We've gone over a lot of new things, including the gravity load, some new constraints, manufacturing settings, and for this particular part, we are going to finally be going over the factor of safety. So briefly before we go into that, let's look at this part because this is new for everyone. Before we were going over this stainless steel hinge, but now we have this steel structural block. And the design space is the entire part. The preserve regions are 0.827 for all 3 cylindrical features. The forces is going to be a 0.5 pound force load, and a 8.827 inches are going to be preserved inside the part. And you could see here in the dotted feature that we're probably going to be expecting a solid rectangular feature once Generative Design has gone through. And we also have constraints, fixed constraints with an offset value of 0.827, a fixed constraint of 0.429 and 0.429 as well in the smaller cylindrical features. So let's taking out the constraints and the preserve regions, keeping the force there, and selecting the generate button. We had the study go for about 10 minutes. And like I said before in our previous videos, that low study time does not mean bad quality. It just means that your part's going through less iterations. And for this, we are finally using the factor of safety. So the yield stress of the steel structural is 38 KSI. We're having a factor of safety of 2, so that gives us an allowable stress that our part can take is 19 KSI. If our part goes over that, then we're probably going to need to change our study quality, or maybe change how the part is just being designed or created as a base. I found that previously when running and testing out these models, I had this surface go pushed all the way up pretty close to the cylindrical feature, and it came out with very poor results. So I found that with topology optimization or generative design, that it's best to have as much material as you can, and then let the software do what it needs to do to have mass reduction. So with that being said, let's take a look at what the construction body is looking like. And let's take out the load. We know that's 0.5, and like we said before, the offset was retained. And showing the stresses, we see that there are high stress values where we probably would expect them to be at the support beams right here. And we notice that the preserve regions of the cylindrical features are the same. And we do notice that there is this unique curvature. So what you could do is that you can go back to reverse engineering and play around with this construction body. Or you can play around with your base with your base. So maybe you might want to keep this a little bit out. So instead of having it go straight, you can have it go up a little bit and then toggle back down. So definitely a good way to kind of figure out how your body is going to look like. Maybe you can do preliminary tests and check, or maybe even reduce the weight afterwards. But there's a lot of different options that you can do here. And if I haven't said this before, definitely with a factor of safety, it does work better with a longer study quality. So this one was run for about 10 minutes, but yeah, factor of safety will take longer study than the previous ones with just mass reduction. And that's just with my knowledge after going through these models. So as you can see here, that's pretty much probably what we were expecting with this load and these type of constraints, the strut-like being bar values being here. So with a final show stress. That is our second to last installment of the 7-part series. Definitely go back and look out for other new features that we have with the loading constraints. Our last video is going to go over multiple load cases, so definitely tune in. We only have one more video, and thanks everyone.